We shall go for one more set of problems on impulse, collision and momentum conservation. The problems are selected from competitive examination papers. As usual, they might require knowledge of other chapters as well. For instance, the first problem will require some results from motion in 1 and 2 dimensions, while the second problem will require a sound base of rotational mechanics. So let us read the first problem. You follow it carefully because it might go out of your view in a few minutes. Problem number 1. The block A of mass 2m is placed on another block B of mass 4m, which in turn is placed on a fixed table. The two blocks have the same length 4d and they are placed as shown in the figure. I shall just introduce the figure shortly. The coefficient of friction, both static and kinetic, between block B and the table, that is given to be mu. There is no friction between the two blocks. A particle of mass m moving horizontally along a line passing through the center of mass of block B and perpendicular to its face with speed v collides elastically with B at height d above the table. In part A of the question, what is the minimum value of V, which you might call to be V0, required to make the block A topple? And in part B, if V is equal to twice V0, find the distance from point P at which the mass M falls on the table. After the collision, you might ignore the role of friction during collision. Without the figure, the problem is not clear, so let me introduce it in a hurry. This is the tabletop shown, and there are two blocks. There is a block, as you can see, lying on the table. This is block B, and on top of that another block which is named block A is placed. Both the blocks have the same length, which is given to be 4d, as you can read the question, and I'm just writing in my figure as well. The upper block is block A. This one's mass is twice m. The lower block is block B, and this one's mass is 4m. And you can see the tabletop here on which the block B is sitting. The length of both the blocks is the same, which is given to be 4d. What next? The coefficient of friction between block B and the table is mu. That is, this table is rough, and between the bottom of block B and the table, frictional coefficient is mu, whether it's static or kinetic. On the other hand, between the blocks A and B, there is no friction. A particle of mass m moving horizontally along a line passing through the center of mass of B. Assuming this block B to be a rectangular block of uniform density, the center of mass is located at a point which is halfway through the length and halfway through the height. I'm talking about this point. This is the center of mass of block B. And if I might draw a dashed line through this center of mass of block B, here is a particle approaching block B from the left with a velocity of v. They are telling here the mass of this particle is small m and its velocity vector is v to the right, and since it's moving in the direction a line that is passing through center of mass of this block B, we conclude that, well, they have already given here the block B has got a height of 2d, and therefore the line of approach of the particle of mass m above the tabletop, that height will be d only, isn't it? Because this dashed line of approach is passing through the center of mass of the block B. This is the question, and the first part of question tells that what is the minimum value of this v, that is speed of this particle, so that after the collision between the particle and block B, the block A might topple on block B. That is the first part of the question. And second part, if the value of the speed of approach of particle v was twice the minimum value v0 required as described in part A, find the distance from point P. Well, this point, that is the left bottom corner of block B, this point they are calling it to be the point P. With respect to this point P, at which point this particle of mass m will be falling on the table, we have to find that after the collision. We might ignore the role of friction during the small brief time of contact between the particle and the block B. This is the complete question here. Once we understand the situation of the problem completely with the help of this figure, let us choose our coordinate system conveniently. I shall take direction to the right. That is my plus x direction, and direction vertically upwards as my plus y direction. We shall now consider the elastic head-on collision between the particle of mass small m and the block B of mass 4m. And we can apply the principles of conservation of linear momentum and conservation of kinetic energy simultaneously to get the velocities of the particle and the block B immediately after the collision. But I'm not going to write those principles or the applications of them. We have got ready-made formulas available with us for elastic one-dimensional collision between two particles. Before I write them, let me take for convenience for the particle, I just want to assign this number 1. So for the particle that is numbered 1, initial velocity before the collision, u1, the symbol is u1 in my formula, as you recall from my classes on collision, u1 is given to be v in the plus x direction, and the mass of the particle, let me call it m1, this is known to be m. And if block B, the other item in this collision, if it is assigned a number 2, for it, before the collision, u2 initial velocity u2 was 0 because the block B was initially at rest, and the mass of block B, let me call it m2, and this m2 is known to be 4m. Once I use the symbols for these two colliding particles, colliding bodies, we recall that for an elastic head-on collision, the velocity of the particle numbered 1 immediately after the collision, this v1 has got a formula. This v1 is given by m1 minus m2 divided by m1 plus m2 into u1 plus twice m2 u2 divided by m1 plus m2, isn't it? You have learned this formula while teaching about elastic collision in one dimension. In our case, as we can see, m1 is m, m2 is 4m. I'm just putting the values here. m1 is m minus m2, that is 4m, divided by m plus 4m. u1 is equal to v. And since u2 is 0 for the block B initially at rest, second term just vanishes, and you get this is coming out to be, as you can see, m's cancel out, that is minus 3v by 5. That's equation number 1 for me for future application. You have got just after the collision, the particle of mass small m rebounds backwards, that is in the minus x direction, therefore the minus sign, with a speed 3 by 5 times its original speed before the collision. Similarly, we have also got a formula for the speed or velocity rather of the block B after the collision. V2 is given by the formula 2 into m1 u1 divided by m1 plus m2 plus m2 minus m1 divided by m1 plus m2 into u2. Once again putting the values, twice m1 is simply m, u1 is equal to v divided by m1 is m and m2 is 4m. This is the first term, and second term is vanishing because u2, the block B initial velocity is 0. So This is of course 0. Second term I'm getting once again. Small m cancelling out and V2 is coming out to be twice V by 5. Just check it, equation number 2.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.